here today to introduce to you the other alternative energy, often referred to as ocean energy. We refer to it as marine renewables because the technologies I'm about to introduce to you can be applied in not only in ocean currents and tidal currents, but also river currents and constructed or man-made waterways such as canals and aqueducts. Our first pilot project is underway, is in New York City on the East River, which is actually a tidal channel. And we are in the east channel of the East River, and there is where we're doing our first project. And we have a second project site identified right in front of the United Nations. This year, we'll be filing for a FERC license. So it'll be a pilot commercial license for 30 turbines that we'll be putting into the East River. We have to date have a little over 7,000 operational hours of this technology, and we have delivered now over 50 megawatt hours of electricity. This year we will be filing for a FERC license, and given the year's process, we should see getting a commercial project underway in late 2009 in New York. In the East River, we're learning a lot about the technology in terms of capacity factor, 30% capacity factor, but a very high capacity value because of the predictability and reliability of the tidal flows. We know when power is coming on, when it's going off. Also, we are designing a different type of deployment system, which will be gravity-based, making it really easy to go in and out of the water, easy to move them around. You increase the size of the rotor for the depth of the water and the speed of the water, you have larger generation. In New York, we have a 5 or a 16-foot diameter rotor, 5-meter diameter rotor with a 35 kilowatt generator. In the St. Lawrence River, same size rotor, but it'll be a 70 kilowatt generator because it's a half a knot faster waters. Go up in size to the St. Lawrence or to the Bay of Fundy, for example, or here around this area, you could have an 11-meter size rotor, again all underwater, not seen. Turns very slowly, only about 35 RPMs, and there with a 4-knot, or I'm sorry, with a in case we going from let's say 2 meters per second to 4 meters per second, you could have as much as a megawatt in each generator in each turbine, again all underwater. The support we have to date has been about $12 million from government in addition to private equity investment into the company. But in addition to working on tidal and river systems, we also have systems that we're designing in Texas for applications in California on canals and aqueducts and waterways. This system is designed to work in shallow, slow-moving water with a vertical axis turbine, something we learned about on the Merrimack River, versus a horizontal axis turbine. And once it works in canals, it can also start working in shallow or slower waters. We don't know what the potential could be for Massachusetts, but we would like, just like we did for the TVA, go into more serious resource assessment to really examine these waters to see what the energy potential is. Needless to say, working in the water gets very interesting in terms of the offsets to not burning coal or oil, the environmental benefits certainly because there's no emissions coming out, but most importantly is even thinking about the economic benefits. Besides job creation and building a whole new industry here, it's this idea of the energy-water nexus. Energy uses water, water uses energy, we're running out of both. So there's opportunities here to create new businesses, new industries, such as the integration of renewable energy systems. Might these types of systems be coupled up with underwater, be coupled up with wind? In canal systems, might they be covered with solar collectors using the hydro systems underneath? So together, you're producing more electricity that can be dispatchable. Fuel cells, off-peak hours, while the tide is flowing, the river is flowing, no way to store the water, might you use electrolysis systems to extract hydrogen from water for stationary fuel cells. Or in the future, might there be fuel cells on board boats that could be filling up at sea, if you will, using water currents and electrolysis. So our ideal product is to create an integrated water and clean energy system. And that's where all this is leading. So reverse osmosis is quite simple. You're just taking the mechanical power from rotors and using that as a pump to pump dirty or salt water through electrified membranes that are being electrified by the electricity that are generated. Aeration systems, you could be pumping oxygen into anoxic waters. So I would leave you with this thought. The idea of what we're doing with these technologies is to help build sustainable communities. And as we're working with the community of New York and New York City, as we're working with the province of Ontario and the city of Toronto, we would love to be able to work with the state of Massachusetts